Question 1. What is the primary benefit of using isolated and consistent training environments in MLOps? Option A. To reduce the total cost of cloud compute resources. Option B. To enable consistent model training results and resolve "it works on my machine" issues. Option C. To provide real-time model inference capabilities. Option D. To simplify data ingestion from various sources. The correct answer is to enable consistent model training results and resolve "it works on my machine" issues. Here's the explanation. The overview states that the primary goal of a well-designed training environment is to enable consistent model training results irrespective of execution details, directly addressing "it works on my machine" syndrome and dependency conflicts. Question 2. In the context of MLOps training environments, what is the main advantage of using containerization technologies like Docker? Option A. It automatically performs hyperparameter tuning for the model. Option B. It ensures data encryption for sensitive training datasets. Option C. It packages code, runtime, and dependencies into an isolated unit, ensuring consistency across environments. Option D. It provides real-time monitoring of model performance in production. The correct answer is, quote, "It packages code, runtime, and dependencies into an isolated unit, ensuring consistency across environments." Question 3. Which technology is commonly used in MLOps to orchestrate and manage the execution of containerized training jobs on a cluster of compute nodes? Option A. Apache Spark. Option B. Git. Option C. Kubernetes. Option D. SQL database. The correct answer is Kubernetes. Here's the explanation. The "How it works" section explicitly states that an orchestration system, most commonly Kubernetes, pulls this Docker image from the registry. Kubernetes then schedules and runs the containerized training job on a cluster of compute nodes. Question 4. What is the primary purpose of managing training artifacts in MLOps? Option A. To reduce the storage cost of machine learning models. Option B. To ensure reproducibility, traceability, and efficient deployment of ML models. Option C. To solely store the final trained model file for production use. Option D. To provide a platform for real-time model inference. The correct answer is to ensure reproducibility, traceability, and efficient deployment of ML models. Here's the explanation. The study material explicitly states that the primary goal of managing training artifacts is to ensure reproducibility, traceability, auditability, and efficient deployment of ML models, encompassing more than just storage or inference. Question 5. Which of the following is not typically considered a key component of training artifacts in MLOps? Option A. The serialized form of the trained machine learning model. Option B. A precise reference to the exact dataset used for training. Option C. Real-time inference request logs from a deployed model. Option D. The specific version of the source code used for training. The correct answer is, quote, real-time inference request logs from a deployed model. Here's the explanation. Real-time inference request logs are part of model monitoring in production, not outputs generated times the model training process. The other options are explicitly listed as key components of training artifacts. Question 6. A data scientist needs to fully reproduce the exact conditions under which a specific machine learning model was trained 6 months ago for an audit. Which set of training artifacts is most crucial for achieving this goal? Option A. Only the serialized model file and its performance metrics. Option B. The training code version, environment configuration, and hyperparameters. Option C. The training data snapshot, training code version, environment configuration, and hyperparameters. Option D. Just the model checkpoints and deployment logs. The correct answer is, quote, the training data snapshot, training code version, environment configuration, and hyperparameters. Here's the explanation. For full reproducibility and auditing, the study material emphasizes that training artifacts provide the complete lineage, the exact data version, code version, hyperparameters, and environment. The model file and metrics alone are insufficient, and deployment logs are post-training. Question 7. What is the primary motivation for implementing checkpointing in MLOps during model training? Option A. To reduce the initial setup time for training environments. Option B. To ensure full reproducibility and enable recovery from interruptions during long-running training jobs. Option C. To automatically perform hyperparameter tuning. Option D. To minimize the amount of data required for training. The correct answer is to ensure full reproducibility and enable recovery from interruptions during long-running training jobs. Here's the explanation. The overview states that the primary motivations for checkpointing are fault tolerance, resilience, efficient resource utilization, and reproducibility, enabling MLOps pipelines to gracefully recover from failures and resume training from the last save state. Question 8. When implementing checkpointing for an ML model, which components are typically saved to ensure seamless resumption of training? Option A. Only the model's learned weights and parameters. Option B. Only the current training epoch number and random number generator states. Option C. The model's learned weights and parameters, the optimizer's internal state, and the current training epoch/step. Option D. Only the raw input data and feature engineering scripts. The correct answer is, quote, the model's learned weights and parameters, the optimizer's internal state, and the current training epoch/step. Here's the explanation. The overview specifies that a checkpoint typically includes the model's learned weights and parameters, the optimizer's internal state, such as momentum, learning rates, or adaptive gradient states, the current training epoch or global step number, and potentially the state of random number generators for full reproducibility. Question 9. For robust fault tolerance in cloud environments, where should ML model checkpoints primarily be stored? Option A. In the local temporary disk of the training compute instance. Option B. In the TMP directory of the container running the training job. Option C. In persistent, highly available cloud object storage, e.g., Amazon S3, Google Cloud Storage, Azure Blob Storage. Option D. Directly embedded within the model's source code repository. The correct answer is in persistent, highly available cloud object storage, e.g., Amazon S3, Google Cloud Storage, Azure Blob Storage. Here's the explanation. The storage location feature emphasizes that checkpoints must be stored in persistent, highly available storage, typically cloud object storage services. This ensures durability and accessibility from any compute instance, even if the original training instance fails. Local storage is ephemeral and not durable. Question 10. What is the primary purpose of model retraining in an MLOps lifecycle? Option A. To find the optimal hyperparameters for a newly developed model. Option B. To continuously adapt an existing production model to changes in real-world data and maintain its performance. Option C. To manually fix bugs in the model's underlying code or architecture. Option D. To redeploy an existing model version to a new infrastructure without any changes. The correct answer is, quote, to continuously adapt an existing production model to changes in real-world data and maintain its performance. Here's the explanation. The overview states that model retraining addresses data/concept drift to ensure models remain relevant, accurate, and performant in a dynamic production environment, thereby extending the utility and value of ML solutions. Question 11. Which of the following MLOps components is * most crucial for ensuring reproducibility and enabling debugging of model retraining runs? Option A. Automated triggering mechanisms. Option B. Resource management. Option C. Data versioning and lineage. Option D. Model evaluation and validation. The correct answer is data versioning and lineage. Here's the explanation. The key features/components section explicitly states that data versioning and lineage, essential for tracking the exact datasets used for each training run, enabling reproducibility and debugging. Question 12. A machine learning model in production begins to show a significant decrease in predictive accuracy, and monitoring systems detect a shift in the relationship between input features and the target variable. Which type of drift has primarily occurred, and what is the most appropriate automated action in a robust MLOps pipeline? Option A. Data drift. Trigger a model rollback. Option B. Concept drift. Trigger a model retraining. Option C. Feature drift. Manually update model hyperparameters. Option D. Model decay. Redeploy the existing model. The correct answer is concept drift. Trigger a model retraining. Here's the explanation. The exam tips and how it works sections differentiate between data drift, input data distribution change, and concept drift, relationship between input and output changes. A drop in performance and a shift in the input-output relationship indicates concept drift, which necessitates retraining to adapt the model. Question 13. What is the primary function of a model registry in an MLOps pipeline? Option A. To store raw input data for training machine learning models. Option B. To serve as a centralized repository for version control, metadata tracking, and lifecycle management of trained models. Option C. To perform real-time inference and serve predictions to end users. Option D. To manage feature engineering pipelines and store feature definitions. The correct answer is, quote, to serve as a centralized repository for version control, metadata tracking, and lifecycle management of trained models. Here's the explanation. A model registry is defined as a centralized repository and management system for ML models, providing version control, metadata tracking, and lifecycle management capabilities. It's the definitive source of truth for trained models. Question 14. Which key feature of a model registry is crucial for enabling controlled promotion of models through various environments, e.g. from staging to production, and ensuring only approved models reach production? Option A. Model versioning. Option B. Metadata management. Option C. Lifecycle management. Option D. Model lineage. The correct answer is lifecycle management. Here's the explanation. Lifecycle management defines and manages distinct stages for models, such as staging, production, or archived, facilitating controlled promotion and ensuring quality checks before deployment. Question 15. A data scientist has trained a new model and evaluated its performance, which proved promising. What is the next typical step involving the model registry before the model is considered for production deployment? Option A. The model is immediately deployed to a production inference endpoint. Option B. The model's raw output predictions are logged into a feature store. Option C. The model artifact is registered with the registry, along with essential metadata, and often placed in a staging or development stage. Option D. The model's training code is committed to a Git repository, bypassing the registry. The correct answer is the model artifact is registered with the registry, along with essential metadata, and often placed in a staging or development stage. Here's the explanation. After training and experimentation, the model is registered with the registry, including uploading the artifact and providing metadata. It's then typically placed in a development or staging stage for further testing before production deployment. Question 16. What is the primary benefit of implementing robust model versioning in an MLOps environment? Option A. To decrease the storage requirements for model artifacts. Option B. To enable reproducibility, auditability, and reliable deployment of ML models. Option C. To automatically optimize model hyperparameters during training. Option D. To solely track changes to the model's source code. The correct answer is to enable reproducibility, auditability, and reliable deployment of ML models. Here's the explanation. Model versioning systematically tracks all aspects of a model's creation: data, code, parameters, metrics, ensuring that its behavior can be reproduced, audited for compliance, and reliably deployed or rolled back. Question 17. A comprehensive model versioning system tracks more than just the serialized model file. Which of the following sets of metadata is crucial to associate with each model version for complete lineage and reproducibility? Option A. Deployment timestamp, inference latency, and user feedback. Option B. Training data version, hyperparameters, training code version, and evaluation metrics. Option C. Cloud region, cost of training, and number of API calls. Option D. Model serving endpoint URL, monitoring dashboard link, and stakeholder names. The correct answer is, quote, training data version, hyperparameters, training code version, and evaluation metrics. Here's the explanation. Complete model lineage requires tracking the specific training data, the hyperparameters used, the exact code version that trained it, and its performance metrics to ensure reproducibility and auditability. Question 18. An MLOps team uses an alias, production, to refer to the currently active model. When a new model version, version 2.1, is promoted to production, the production alias is updated to point to version 2.1. If version 2.1 then exhibits unforeseen issues, how does model versioning facilitate a quick fix? Option A. By automatically retraining version 2.1 with new data. Option B. By deleting version 2.1 and forcing a manual redeployment of an older version. Option C. By updating the production alias to point back to a previous stable version, e.g., version 2.0. Option D. By initiating a new A/B test with version 2.1 and another experimental model. The correct answer is by updating the production alias to point back to a previous stable version, e.g., version 2.0. Here's the explanation. The ability to quickly revert to a previous stable production version by simply repointing the production alias is a key benefit of model versioning, enabling rapid rollbacks and minimizing downtime. Question 19. What does model metadata primarily refer to in the context of MLOps? Option A. The raw input features used to train a model. Option B. Descriptive information about a machine learning model artifact itself. Option C. The ground truth labels used to evaluate model performance. Option D. The compiled binary code of the model for deployment. Correct answer is, quote, descriptive information about a machine learning model artifact itself. Here's the explanation. Model metadata refers to descriptive information about a machine learning model artifact. It is data about the model itself, rather than the data used to train the model or the predictions generated by it. Question 20. Which of the following is a crucial piece of lineage and provenance metadata typically associated with a registered model? Option A. The current real-time inference latency. Option B. The specific training run ID that produced the model. Option C. The number of active users interacting with the deployed model. Option D. The cost of the cloud instance where the model is hosted. The correct answer is the specific training run ID that produced the model. Here's the explanation. Under lineage and provenance, in key features, training run ID is listed as a reference to the specific experiment run that produced the model, making it a crucial piece of metadata. Question 21. How does model metadata facilitate automated model rollbacks in MLOps pipelines? Option A. By directly executing the rollback commands without needing model information. Option B. By providing the necessary information, e.g., version, performance metrics, artifact location, to identify and redeploy a previously stable version. Option C. By solely relying on external human approval for every rollback decision. Option D. By automatically generating new training data for the model. The correct answer is by providing the necessary information, e.g., version, performance metrics, artifact location, to identify and redeploy a previously stable version. Here's the explanation. If a deployed model performs poorly, its metadata allows quick identification of the training run, dataset, and code version. The ability to rapidly revert to a previous, known good model version is entirely dependent on having accurate and accessible metadata for each historical version. Question 22. Which of the following best describes a model artifact in the context of MLOps? Option A. Only the serialized model weights, e.g., AH5 or .pkl file. Option B. The raw dataset used to train the model. Option C. A complete, versioned package including the trained model, pre/post-processing logic, environment dependencies, and metadata required for deployment and understanding. Option D. The user interface for interacting with the deployed model. The correct answer is a complete, versioned package including the trained model, pre/post-processing logic, environment dependencies, and metadata required for deployment and understanding. Here's the explanation. A comprehensive model artifact extends beyond just the serialized model weights. It encapsulates the trained model itself, any associated pre-processing and post-processing logic, the exact environment dependencies, input/output schemas, training metadata, and often the code that generated the model. Question 23. Why is proper management of model artifacts crucial for reproducibility and reliable deployment in MLOps? Option A. It simplifies the process of collecting new training data. Option B. It ensures that the exact same model behavior can be guaranteed across different environments: development, staging, production. Option C. It automatically tunes hyperparameters during model training. Option D. It primarily focuses on real-time monitoring of model performance in production. The correct answer is it ensures that the exact same model behavior can be guaranteed across different environments: development, staging, production. Here's the explanation. The core purpose of managing model artifacts is to ensure reproducibility, auditability, and reliable deployment across different environments. Without proper artifact management, deploying a model reliably becomes a significant challenge, leading to issues like "works on my machine" syndrome. Question 24. After a model artifact is packaged, where is it typically stored, and how is it then managed for deployment? Option A. It is stored directly on the training machine and manually copied to production servers. Option B. It is stored in a durable, versioned artifact store, e.g., object storage, and registered in a model registry for lifecycle management. Option C. It is embedded directly into the training script and regenerated upon each deployment. Option D. It is only kept in a temporary cache until deployment is completed. The correct answer is it is stored in a durable, versioned artifact store, e.g., object storage, and registered in a model registry for lifecycle management. Here's the explanation. The packaged model artifact is stored in a durable, versioned artifact store, like Amazon S3, Azure Blob Storage, or Google Cloud Storage. Its location and metadata are then registered in a model registry, which acts as a central hub for managing model versions and facilitating deployment. Question 25. What is the primary purpose of model lineage in MLOps? Option A. To primarily manage the cost of cloud resources for model training. Option B. To provide a comprehensive, auditable, and traceable record of a model's entire lifecycle. Option C. To automatically retrain models when performance degrades in production. Option D. To simplify the process of hyperparameter tuning during model development. The correct answer is to provide a comprehensive, auditable, and traceable record of a model's entire lifecycle. Here's the explanation. Model lineage refers to the comprehensive, auditable, and traceable record of the entire lifecycle of a machine learning model, ensuring transparency, reproducibility, and governance. Question 26. Which of the following is considered a key component of model lineage, tracking the exact software and hardware environment used for training and deployment? Option A. Data lineage. Option B. Code lineage. Option C. Environment lineage. Option D. Experiment tracking. The correct answer is environment lineage. Here's the explanation. Environment lineage specifically captures the exact software and hardware environment where the model was trained and deployed, including OS versions, library dependencies, and compute resources. Question 27. A financial services company needs to explain why a specific loan application was denied by an ML model to a regulatory body. Which aspect of model lineage would be most critical for this task? Option A. Resource utilization monitoring. Option B. The ability to trace the model back to its specific training data, code version, and configurations. Option C. Automated model retraining pipelines. Option D. Real-time inference latency metrics. The correct answer is the ability to trace the model back to its specific training data, code version, and configurations. Here's the explanation. Model lineage provides the necessary audit trail to show which data sources were used, how data was transformed, what algorithms were applied, and how model fairness or privacy considerations were addressed, satisfying requirements from auditors or regulatory bodies by providing a transparent and verifiable history. Question 28. What is the primary purpose of defining model stages in an MLOps model registry? Option A. To reduce the size of model artifacts for faster deployment. Option B. To enforce governance, ensure quality control, and enable structured deployment strategies. Option C. To automatically retrain models when performance degrades in production. Option D. To provide a platform for data scientists to experiment with new algorithms. The correct answer is to enforce governance, ensure quality control, and enable structured deployment strategies. Here's the explanation. Model stages are fundamental for managing the complete lifecycle of an ML model, enforcing governance, ensuring quality control, and enabling robust versioning and deployment strategies. Question 29. An MLOps team wants to quickly revert a problematic production model to a previous stable version. Which key feature of model stages directly facilitates this action? Option A. Metadata management. Option B. Approval workflows. Option C. Rollback capabilities. Option D. Automated workflows integration. The correct answer is rollback capabilities. Here's the explanation. Rollback capabilities allow organizations to quickly revert a production model to a known good previous version by simply changing the stage pointer in the model registry. Question 30. In an MLOps model registry, a data scientist registers a newly trained model. What is the typical initial stage assigned to this model version, indicating it's not yet ready for deployment? Option A. Production. Option B. Archive. Option C. Staging. Option D. None or development. The correct answer is none or development. Here's the explanation. When a model is first registered, it's typically assigned an initial stage like none or development, indicating it's in its initial state and not yet ready for pre-production or production deployment. Thanks for watching. Please subscribe to my channel.